Second statistics video, we're going to look at graphing quantitative discrete data. More exact, we're going to look at three types of graphs that we can use with discrete data. That is the dot plot, the box plot, and the stem and leaf plot. So let's first look at how to determine a box plot. It's simple. You just make a number line of your data point, and then you make a dot or an X for each data point along the number line. Notice that when I have one value, I have it at the same height above the number line. And then 2, same height above the number line as the other 2, and then 3. And basically, these just makes sort of like a bar. So we're just plotting individual data, and that makes us our dot plot. When you finish, you can usually see the mode of the data, which occurs most often, and you can see the distribution of the data. So first, we're going to learn about how to find range. Range is simply the max value minus your minimum data point. So our max here is 84 and our minimum is 68. So our range of data would be 16. We go through 16 values. In this case, our unit measurement is inches. The mode is the one that occurs most often. So it's easy in this distribution for us to see that the mode is 75 inches. And then how many players are greater than 70 inches tall? Well, I just count how many players that are above the 70. Here's another dot plot. This time, instead of making circles, they made X's. So we're going to do the same thing. What is the range of the pulse rates? So remember, that's our max minus our min value to get our range. So that's 85 minus 79. The range of pulse rates for these 16 boys in gym class is 6. How many boys have a pulse rate of 81? So I just count up my 81. Have a pulse rate over 81, that'd be 9. How many people have a pulse rate of 83? That's 4. And how many people have at most 82? So that counts the 82 and below. Okay, now we're going to look at our second type of graph, which is called a stem plot. Sometimes this is also called a stem and leaf plot, and you'll see why in a moment. So one thing we need to do is we need to separate each observation to stem, which is all but the final digit, and our leaf, which is our final digit. And then we're going to write all possible stems of the smallest to the largest. And then we're going to make a vertical line. And then we're going to plot each leaf in rows. Then we're going to put them in increasing rows, and then we're going to make a key. So you usually kind of do these in 2 stages. So first, here's all my leaves, and that's the first digit of each number. And now I'm just going through each data point, and I'm plotting the numbers as I come across them, just in the order in which they're written in the raw data. Step 2 is we're going to make another data, but this time we're going to arrange our values into increasing order. So I have 3 13s, 1 15, and 1 19. And we're going to do the 20s. And then the 30s. The 40s. How many people have 50 shoes or more? Okay. Once you have your graph in increasing order, then you're going to make a key. Now, key is you just choose one random data point or a point that's not even existing in your data range. I choose 31, and then tell us what that represents. Well, 3/1 represents 31 pairs of shoes. And you cannot have a stem and leaf plot without a key. Very, very important that you always include your key. Now notice these make also nice and pretty bars that you can easily see which is the most popular values. So let's answer some questions about this other stem plot that happens to do with the truncated weekly incomes in hundreds of dollars of a family. So the highest value was 6.2, but that 6 and a 2 translates to $620 a week. Okay, and the lowest value would be 1/9, which translates to $190 per week. So what's the difference between the highest and lowest values? Well, that's just the range. So I take the 620 minus the 190, and I get $430. How many families can earn more than 500? Well, that's just 3 families. That's the 550, the 601, 610, and 620. And what is the range? Does 4/2 represents? Well, that's $420 per week. Now here's another stem leaf plot, but notice in this data we have an awful lot of data points with 1. So sometimes you can do halves, whereas this first line represents everything from 0 to 4, and then the second one is 5 through 8. And it just makes it a little bit easier to get our data when we have a lot in one leaf. One stem. You usually only use this if you have less than 4 stems without breaking it up, or if you have a normally large amount in one stem, which I did here in my one stem. So that's the reason why I broke it apart. And again, once I had all my raw data put down, to get your final stem and leaf plot, you need to put it in increasing order. So I'm just going back through and rewriting my data points into increasing order. Remembering trying to space my values equally spaced each time so I can get a good picture of what the distribution looks like. As you can see here, my data is extremely skewed, and it's a positively skewed data. We have the tail going toward the positive direction. And finally, the last thing I do is put a key. So 2/3 represents a person who is 23 years old. And now I have my completed stem and leaf plot. All right, so let's look at our data. How many people attended the meeting? We'll have 34 data points, so 34 people. What's our youngest person, which is 12 years old, and our oldest is the 58. And what age group are most widely represented? Well, that would be the teenagers from 15 through 19 years of age. Another common way we're going to do stem plots is going to be a back-to-back stem and leaf plot. And that's where you put two data that are comparing basically the same information. So here I have Texas rainy days versus California rainy days. And so I'm going to do Texas rainy days in blue, and they're going to be on to the left. And then I'm going to do the California rainy days to the right of the stem. But they're always, both days have to use the same stems. Oops, I didn't quite get enough, so let's try this again. I have to go down to 11. So now I'm just going to go through my Texas days and just put them in order. Notice that I start counting out from the stem and toward the trail of the leaves. Okay, in green, I'm going to do California's rainy days for each year. Now that I have my random one completed, I'm going to make my stem and leaf plot, and I'm going to do it in increasing order. So on the left, when I do Texas values, I'm going to start from closest to the stem, and then as I go away from the stem, the values increase. Equally spaced between each values. And now I'm going to do my green, which is California's. And as I go away from the leaves to the values, away from the stem, the leaves values increase. I'm going to make my key. I'm going to let 2 to last 7, which is not a data point, but it's okay, represent 27 rainy days in a year. Since I have two stems and leaves, you always want to go back up here and name which leaf, which data is reported, and which value. Okay, our next type of graph we're going to learn is called a box plot. It looks something like this. We have some box and whiskers on the side. In order to do this, the first thing you have to do is come up with something called the 5-number summary. It consists of these 5 things: the minimum value, quartile 1, the median, quartile 3, and the maximum values. Well, the minimum value, we already learned, is the smallest data point, the value. And our maximum value is our largest data value. Our median is our data value in the middle, and we learned that in our video 1. And of course, none of this works unless we have it ranged in increasing order. Quartile 1 is the median of the data points is below the median. So it's the middle number for all data below the median value of the data point. And quartile 3 is the median of all the data above or greater than the median value. Okay, then we're going to draw a number line, plot our 5-number summary in this order. The whiskers are the max and mins, The box starts with the quartile 1, the line in the middle of the box is the median, and then quartile 2. So let's look at this small data set, and we're going to construct our first box and whisker plot. So first thing I need to do is rearrange my data into increasing order. You can do this any way you want to, as long as your numbers are increasing. And then I have 8 data values, so I have 2 numbers in the middle. So I need to find my 5-number summary. My minimum value is 40. Quartile 1 we'll come back to in a minute. Median we'll come back to. Quartile 3. And then max value I can easily find is 67. So then I'm going to find my median. And that's the number in the middle. So again, I have 8 data sets, so I have 2 numbers in the middle. So I need to add them together and divide by 2. So 51 is my median. Then I take all data values below that 51, which will be these 4 data, and find its median. So quartile 1 is 41 plus 42 divided by 2, which will be 41.5. Quartile 3 takes all data points above the 51 median. And again, I have 2 data points in the middle, so I add them together, and I'm going to divide by 2, and I get 64.5. Now I'm going to plot these 5 numbers above the number line, not on the number line, above the number line you made. So remember, the median is just a dot. Quartile 1, median, and quartile 3, we draw a line. We connect those lines to form our box. And then we do a dot for our maximum value. And then we connect the maximum value to our box with a line. Then we go back, and it's always helpful to label your 5-number summary onto your data, your graph. In our next example, we're going to look at interpreting data from a box plot. So what is our high score? Well, that's our maximum value, which is 102. What percentage of the students score above 72%? Well, quartile 1 represents 25% of our data, median is 50% of our data, and quartile 3 is 75% of our data. So a percentage class scored above 72. So that would be, since quartile 1 is 25% of our data, it would be 75. What is the median score? Well, that's 88. What percentage people scored between that? Well, that's 1 quartile, so that's 25%. And then, do you think that the test was too hard for the students? Explain. Well, no. And the reason for that is we know 75% of the students scored 72% or above on the exam. And we know that 50% of the students scored 82% or above. And 25% of students made 96 or above on the exam. So that's the reason why I don't think it was too hard. Okay, would you explain that the median is above or below the mean? Well, in a previous video, we talked about mean, median, and mode, and we also talked about symmetry of data. Well, if you have symmetric data, your mean will be approximately equal to your median. If your data is negatively skewed, then your mean would be less than your median. And if your data is positively skewed, your mean will be greater than your median. So looking at this, I have negatively skewed data. So I have that tail going off to the left. And how you tell that is you look at the box itself. And if your median is closer to the quartile 1, you have positively skewed data. If your median is close to the middle of your box, you have symmetric data. And if your median is closer to the quartile 3 of your data, you have negatively skewed data. So since this data is negatively skewed, the mean, I would expect the mean to be less than the median. In our next example, we're going to look at 2 side-by-side box plots. In question 12, what percentage of sophomores watch TV at least 15 minutes per night? Well, that'd be 75% because it's 15% is quartile 1. Okay, what 3/4 of the TV per night? That's 110 minutes. Is it more common for sophomores at the high school to spend more than 1 hour on homework or on television? Obviously, it's television. How do I know that? Well, we know the median for the television is 60 minutes, whereas quartile 3 is 60 minutes for homework time. So that means that more than 50% of students watched television for 60 minutes or more, while only 25% of students did their homework for over 60 minutes. Okay, true or false? Yes, it's true that some sophomores didn't watch TV that month because we have a minimum value of 0. TV box whisker plot contains more data than the homework plot. Well, false, or not enough information to figure it out, because that's the downside of a box plot. It doesn't tell us how much data points. It just tells us our minimum values, our quartile 1, quartile 2, and our median value.